Hi viewers, this is Sri Ramulu, DL in Physics. YouTube channel is s.s Physics. So before watching this video, please subscribe it. So today's topic is important topic, that is the Thevenin's theorem. What is the Thevenin's theorem? Its statement is there. Okay, any two terminal linear bilateral network consisting of DC sources and a number of resistors can be replaced by a equivalent DC voltage source V Thevenin's in series with a resistor or Thevenin's. Okay, so this is the statement. So what he is saying, whatever resistance present, so all the resistance you must replace by R Thevenin's. Okay, and whatever voltage you have, so all the resistor voltage you must replace by V Thevenin's, and connect these two things, connect this resistance with this voltage in series. That is a statement of Thevenin's. And the proof of Thevenin's. What is the proof of Thevenin's? See here. Here V Thevenin's is the Thevenin's equivalent voltage is the open circuit voltage between the terminals A and B, and R Thevenin's is the Thevenin's equivalent resistance. Is the resistance between the same terminals. Okay, so which terminals you selected, so in between those terminals voltage is the Thevenin voltage and resistance is the Thevenin resistance. And proof is step by step proof is there, step by step procedure to find Thevenin's equivalent of a given network. See here. Step 1, what is it? Explain. Everyone must by heart all the steps, then only you can easily understand. So for every steps I have given the diagram, I have explained with the diagrams also. First step, what is the first step? I can explain to us. Identify the two terminals of network which it is to be Thevenized. Okay, so first what we have to do, if the circuit is given, in that circuit we have to identify where the Thevenin's voltage we have to calculate. Okay, so first, if any circuit is given, first we have to identify the two terminals, means 2 points where Thevenin's voltage and Thevenin's resistance is calculated. That is the meaning of this. Okay, redraw the circuit keeping these two terminals open. Which terminal you selected, first to open them. Now see the diagram here. In this diagram, let me select the here, it is the actual diagram. One voltage is given, RA, RB, RC, 3 resistance, along with one more resistance is there, that is RL. RL is called load resistance. Load resistance means where we are going to calculate voltage, or where we are going to draw the voltage or take the voltage, that resistance is called load resistance. Okay, so this is the load resistance. At this point we have to calculate V Thevenin's and R Thevenin's. Okay, so I have selected these 2 points. Let it is A point, it is a B point. So see here in the next second diagram. Now like this 2.2 I selected one region or resistor or points, and I replace them with A and B, and what we have to do, we must keep them open. See in the statement, we must keep them open. Okay, identify two terminals of network which is to be Thevenized. Yes, I identify these two terminals. Okay, why? Because I need here Thevenin's voltage. Redraw the circuit, again draw the circuit. Redraw the circuit keeping these two terminals open. So that is why I kept it is open. See, open means no connection. Short circuit means you have to connect like this. So it is open. Next, step 2. Find the open circuit voltage between the two terminals identified in step 1. This is the Thevenin's equivalent voltage V Thevenin's. Okay, what he is saying. So in the above diagram we have identified the 2 points, 2 terminals, okay, in the step 1, and at this step this is the if you find the voltage at those 2 points, that is called Thevenin's equivalent voltage V Thevenin's. So for this, so for the second step, what V Thevenin's we have to calculate. So there is a small derivation for this circuit is shown in the figure. So it is shown in the figure, it is a figure, and open circuit voltage across AB. So across AB voltage, open circuit voltage is V Thevenin's, and it is the voltage across RB also. Why it is across RB? Because see here, suppose the current is flowing like this, I amount of current is flowing. So this current flows through the RA, but at this point what happens? Part of current has to flow in this direction, part of current has to flow like this. So here the current is dividing. Where the current divides, then those two networks or those two resistors are parallel to each other. If the current is not dividing, they are in series. If the current is dividing, they are in parallel. So in parallel combination, voltage is same. In series combination, voltage is different. In parallel combination, voltage is same. Okay, so here now the voltage across AB, it is parallel to RB. So whatever voltage present at AB, same voltage present at RB. So at RB, if we take it as VB, it is nothing but V Thevenin's. Why? Already I have taken here as V Thevenin's. Same voltage present here. Okay, for this, see the derivation, simple derivation. Okay, now, so this is the because, this is the because once the RL is removed, the terminals AB are open, no current flows through RC. Yes, through this no current flows, so that is why this voltage is equals to this. As no current flowing through RC, it become ineffective, it cannot affect anything. In this situation, RA and RB are in series. See, RA and RB in series. Why? Here, suppose the current, it is open, means this is no current flows. So whatever current coming from the source can flow through RA and through RB. So like this only. So current through this and this, the same current means the current is not dividing. Current not dividing means these two are in series. Series combination formed by their sum only. Okay, so that is why voltage is equals to, voltage across RB is equals to, current across RB is equals to, that is IB. IB is equals to voltage by resistance. How many resistance are there? These two resistance are there, but why they are summed? Because they are in series, that is why they are summed, means plus, added. Now the voltage drop across RB, let it is IB. IB is equals to current into resistance, current through IB and resistance also RB. And see, this VB is what? V Thevenin's. Why? Whatever voltage present here, that is the same. Okay, so here IB, see here, this is taken, this IB take and substitute here, then you can get this one. Okay, so we got this is. So this VB is the V Thevenin's. So not written here, please write here, this VB is equal to V Thevenin's, that is V by RA plus RB bracket into RB. Okay friends, right? This VB is what? This VB is V Thevenin's. sorry, here not written, replace this VB in the next step and write it as Thevenin. So by this we calculated Thevenin. Next step 3, what we have to do in step 3? Step 3, redraw the original circuit replacing all the voltage or voltage sources means batteries with their internal resistances and all the current sources with open circuit. Also keep the two terminals identified in step 1 opens. So in step 1 tools we identified and we kept them open, see here. Okay, and what he is saying, redraw, so it is drawn circuit by, sorry, so it is redrawn, okay, redraw the original circuit replacing voltage source. So here at the beginning there was here one voltage, now it is replaced means short circuited with their internal resistance. Here no need to show the internal resistance, and all the current sources with open, but initially there was no any current source, that is why no need to open here. So only which terminal identified, that is opened. Also keep the two terminals identified in step 1 open. So that is why in step 1 which is identified, that is kept open. Next, it is step 4. What is the step 4? Find the resistance between the two terminals identified in step 1. This is the it is the Thevenin's equivalent resistance or Thevenin's. So now what we have to do in step 4, Thevenin's resistance we have to find. Okay, so come to the diagram, it is a diagram, and see here in the diagram. So there are how many resistance are there? 3 resistance are there. Their resultant resistance is simply R Thevenin's. Their resultant resistance is R Thevenin's. See how can we calculate that resultant resistance? See here. Okay. Suppose initially what there here current voltage source were there. Current how does flows? Current flows like this. So current is flowing through RA, but at this point current is dividing like this. Then these two resistance are in series, in parallel. These two only in parallel. Their combination is series with this. Okay, so that means their combination you must add to the RA. Their combination you must add to the RA, or you can draw like this. Suppose current is flowing like this. Okay, so that current flows through RC. At this point current divided into 2 parts. So that means RA and RB are parallel to each other, and their combination is series with RC. So that is why RA and RB are the parallel to each other, and their combination is series means summed with RC. So I told you in the previous video, if two resistance are in parallel, then simply multiply those two resistance above and below, just add them. Here RA and RB are there, those two are parallel means multiplied above and added below, okay, plus RC as it is. So this resistance is the resultant resistance is called R Thevenin's. Okay. Next, last step. Draw the Thevenin's equivalent circuit with values V Thevenin's and R Thevenin's obtained in step 2 and in step 4. Okay. So here only 2 things you must keep in mind. Second step is used to calculate V Thevenin's. Fourth step is used to calculate R Thevenin's. So you must keep in mind these 2 factors. Second step is used to calculate V Thevenin's. Fourth step is used to calculate R Thevenin's. Okay friends, and R Thevenin's, V Thevenin's we have calculated. Okay, then these 2 R Thevenin. So V Thevenin, see by using them we have to draw the diagram. So using the values of V Thevenin's and R Thevenin's, we can draw the Thevenin circuit diagram. So Thevenin circuit diagram. So it is voltage is V Thevenin's, it is R Thevenin's in series. In the statement see there. So V Thevenin's is series with R Thevenin's, and it is AB. At AB what is replaced? We replace RL. Okay, at AB you can connect RL also. Okay friends, so this is today's topic, and don't forget watching this video till the end. Why? Because this is a very important for the exam point of view. Okay friends, thank you.